The Earth is warming. This is not a drill. The consequences are already upon us. Fiercer storms, deeper droughts, rising seas. We have pushed the planet to its limits and we are running out of time. The culprit is clear: our reliance on fossil fuels. Coal, oil and gas have powered our industries and fueled our cars, but at a terrible cost. They release greenhouse gases that trap heat in the atmosphere, disrupting the delicate balance of our climate. The need for change is urgent. We must transition to clean, renewable energy sources if we are to avert the worst effects of climate change. Solar and wind power have made significant strides, but they are intermittent sources, dependent on the whims of the sun and wind. We need a reliable, always-on source of clean energy. Geothermal energy, the heat that lies beneath our feet, offers a promising solution. Deep within the Earth's core lies a vast reservoir of heat, a remnant of the planet's formation billions of years ago. This geothermal energy is constantly replenished by the decay of radioactive isotopes in the Earth's mantle. In some regions, this heat rises close to the surface, manifesting as geysers, hot springs, and volcanoes. But even in areas without obvious geothermal activity, the Earth's heat can be accessed by drilling wells into underground reservoirs of hot water and steam. Geothermal power plants harness this heat to generate electricity. There are several types of geothermal power plants, but the most common type uses steam from underground reservoirs to spin turbines connected to generators. The steam is then condensed back into water and injected back into the reservoir, creating a closed-loop system. Geothermal energy offers several advantages over traditional fossil fuels and other renewable energy sources. First and foremost, it is a clean energy source that produces little to no greenhouse gas emissions. Geothermal power plants have a much smaller carbon footprint than coal or natural gas plants, making them a crucial tool in the fight against climate change. Second, geothermal energy is a reliable and consistent source of power. Unlike solar and wind energy, which are dependent on weather conditions, geothermal power plants can operate 24 hours a day, 7 days a week, regardless of the sun or wind. This reliability makes geothermal energy an ideal baseload power source, providing a constant supply of electricity to meet our energy needs. Section 4. A steady source in a fickle world. The intermittent nature of solar and wind power presents a significant challenge to their widespread adoption. While battery storage technology is improving, it is still expensive and not yet capable of storing large amounts of energy for extended periods. This means that solar and wind power alone cannot meet our energy demands. Geothermal energy, on the other hand, provides a constant and predictable supply of electricity. This baseload power is essential for maintaining a stable and reliable power grid. Geothermal power plants can operate at high capacity factors, meaning they produce close to their maximum output for the majority of the year. This makes them a valuable asset in the transition to a cleaner and more sustainable energy future. Section 5. Geothermal in action. Geothermal energy is already being used successfully in many parts of the world. Iceland, a country located on a geothermal hotspot, generates nearly 30% of its electricity from geothermal sources. The United States, the world's largest producer of geothermal electricity, has several large geothermal power plants in operation, primarily in California and Nevada. Kenya has also emerged as a leader in geothermal energy, with its Olkaria geothermal field being the largest in Africa. The Philippines, Indonesia, and New Zealand are other countries that have successfully harnessed geothermal energy to meet their energy needs. Section 6. The path forward. While geothermal energy offers significant potential, there are also challenges and limitations to its widespread adoption. One challenge is the upfront cost of drilling geothermal wells, which can be high. However, technological advancements are reducing drilling costs, making geothermal energy more economically competitive with fossil fuels. Another challenge is the limited geographic availability of geothermal resources. Geothermal power plants are most cost-effective in areas with high heat flow close to the surface. However, new technologies are being developed to access geothermal energy in a wider range of geological formations. Despite these challenges, the potential of geothermal energy to mitigate climate change is immense. By tapping into the Earth's vast heat reserves, We can reduce our reliance on fossil fuels and transition to a cleaner and more sustainable energy future. As we confront the urgent threat of climate change, geothermal energy offers a beacon of hope, a path towards a future powered by the Earth's own natural heat.